operation triangle and inverted triangle, and they are defined like this. So we're asked to find whether the triangle is distributive over the inverted triangle and whether inverted triangle is distributive over that. So this means if I introduce another element here, so if I have a triangle B inverted triangle C, if it's the same as a triangle B inverted a triangle C, you know it's distributive over the triangle. Why this? If you now have a inverted B triangle C, if it's now equal to a inverted B triangle A inverted C. So if it's correct, if the two are equal, the left is equal to the right hand side, you know that is distributive over the inverted triangle. So let's solve for the first one. So I'm solving for the first one. So let me try and do a triangle B inverted C. So we'll first do inverted. So I have a triangle B inverted C is now BC from our definition, and a triangle BC is now A plus, we have BC over 3. So let's check the right hand side, which is a triangle B inverted triangle a triangle C. So as you can see, a triangle B is A plus B over 3. Inverted triangle, this should be A plus C over 3. So we now use inverted, which is now A plus B over 3 times A plus C over 3. So which is A plus B times A plus C over 9. So as you can see, the left hand side is not equal to the right hand side, therefore it is not distributive. As triangle is not distributive over inverted triangle. So why the second one? With the left hand side, let's try the right hand side. So A triangle B, so A upside down triangle B, triangle A upside down C is now equal to A upside down triangle B is AB, as you can see. Triangle upside down, that is AC. So using triangle, for triangle AB triangle AC, as you can see, the triangle is A plus B over, so we have AB plus AC over 3. So which is A bracket B plus C over 3. So what do you notice? The left hand side gives us that, while this is the right hand side. So what do you have to say? Therefore it is distributive. So therefore the operation upside down triangle is distributive over operation triangle. Why operation triangle is not distributive over operation upside down triangle? So that's it. So let's look at identity element. Identity element of a binary operation. Given a non-empty set X which is closed under the binary operation triangle, if there exists an element E, which is an element of the set such that A triangle E equals E triangle A equals A. For all A element of set S, then E, which is element of set X, is called an identity element under the operation. So, and the identity element is always unique if it exists. So what are we trying to say here? It's simple. An identity element is that element that will operate with any other element to give you the same element. So example, identity element of every number is 0. Yes, because if I add, because plus is one of the operation, 1 plus 0 gives us 1, and also 2 times 1 gives us 2. So what do you notice here? 2 is here, 2 is here, 1 is here, 1 here. So the identity element of addition is 0, while the identity element of multiplication is 1. So that's why we use this A triangle E. So E is the identity element. So if we operate with A, it will always give us A. This is just commutative property that are the same. So let's look at this question. They said, example 1, a binary operation on the set of real number excluding -1, so any other real number except -y, is such that for all x and y elements of real number. So this is defined by this. So this is the definition. So we're asked to find the identity element. So let the identity element be E. Be E. So what do you have to say? So let's choose any of the elements. Remember, x and y are the elements of real number. So let's choose x. Let's choose x. Even if you choose y, we still get the same answer. So if x operates with identity element E, it will give us x. That's it. I'm using x. You can use y. So I'm from definition, from definition, x asterisk y is x plus y plus 2xy. So from here you see that x plus e plus 2xe is now equal to x. Remember, our main aim is to find e. So we are looking for e. X minus x. So we are left with e plus 2xe is equal to 0 because x minus x is 0. So remember, we're looking for e, so we'll factor e. I have 1 plus 2x equal to 0. So e is now 0 over what? 1 plus 2x, which is 0. So our identity element is 0. So you matter the elements, the identity element is always 0. So it's very simple. So what of this? You're asked to find the identity element of the table. So whenever you're asked to find, whenever you're given a table and you're asked to find the identity element, just if you notice the elements here are A, B, C, D. So look at this. The first column A, B, C, D. The first row A, B, C, D. The operation is triangle. Just look out for the row and column aside this first row and first column that are arranged as A, B, C, D. So look at this. This is C, A, C, B. So it's not part of it. So you notice that. What do you notice? This. This is A, B, C, D. Are you seeing it? So we have gotten the column. So let's look for row that has A, B, C, D. If you notice, this has A, B, C, D. So what's the point of intersection at B? Therefore, the identity element is B from the table. So option B. So whenever you are given a table, just look out for the arrangements.
first row and first column. So A, B, C, D, A, B, C, D. So we now check another row and column aside the first one that will also ascend A, B, C, D. So as you can see, this is A, B, C, D. This is A, B, C. So their point of intersection is our identity element. That is the point of intersection. So that's it. Let's look at inverse element. Inverse element of a binary operation. So given non-empty set X, which is closed under the operation, binary operation, triangle. So remember I told you you can use any operation. So I prefer using triangle. You can use asterisk, you can use upside down triangle. So if there exists an element, this x raised to power minus 1, which is also an element of the set, such that that's this element x raised to power minus 1, triangle A or A triangle S raised will always give us E. So where E is the identity element, so our E here is always the identity element. So that element, such that if you operate with any other element, it gives you the identity element, is called the inverse element. Yes. So any element that when it operates with another element and it gives you an identity element, know that that element is the inverse. Example now, x now times 1 over x is what? 1. You know 1 is one of the identity element of addition and multiplication. So 1 over x is the inverse of x. So that's it. So let's look at the question. They said a binary operation on the set of real numbers excluding minus 1 is such that for all x and y are elements of real numbers. So they are all real numbers. Then asks us to find the inverse of minus 3. So the number we are going to use here is minus 3. So let the inverse be, we use x raised to the power minus 1. Therefore, if x raised to the power minus 1 operates with minus 3, because that's the one way to get the inverse, it must give us E. So, but we don't know E. How do you get E? We now use the definition of identity element. But an identity element is the element that's if minus 3 combines with E, it gives us minus 3. Yes. So we now use this to get our E. So once we found E, we substitute here. So let's continue. Minus 3 asterisk E. So we use the definition here, which is minus 3 plus E plus 2 times minus 3 times E will give us minus 3. So we'll continue. So this is minus 6, this is minus 3. Okay, minus 3 cancels minus 3 is off. This is E minus 6E. E minus 6E is minus 5E, equal to, remember we've cancelled, so we're left with 0, which implies that E is 0 over minus 5, which is 0. Therefore we'll go back now. S raised to power minus 1, which is the inverse, asterisk minus 3 must give us 0. So we also use the definition, which is defined. So we have x raised to power minus 1 plus times minus 3, which is minus 3. Also plus 2 times that, plus 2 times x raised to power minus 1 times minus 3 must give us 0. So I have, remember our main aim is to find that x raised to power minus 3. So I have x raised to power minus, our main aim is to find x raised to power minus 1. So I have minus 3 goes over to be plus. So I have, this is minus 6 x raised to power minus 1 equals 3. So this minus 6 is minus 5x raised to power minus 1 equal to 3. Therefore, the inverse we are looking for is minus 3 over 5. So that's the answer. So whenever you're asked to find the inverse element, what do? You solve for the identity, then you substitute, and finally use the definition they gave. So our answer is option A. So let's look at the second question. They said find the inverse. We are given this operation, and we're asked to find the inverse of 8. So let the inverse be x raised to power minus 1. Then if x raised to power minus 1 operates with, I use star, operates with e, it must give us 8. That's by definition of identity element, that if any element that operates with identity, it must give us that same element. So let's look for e now. So I have 8e over 2 equals 8. So we have e is 2. So our identity element is what? 2. So we'll go back and substitute e as 2. So let's look for our inverse element. So here, using the definition again, x raised to power minus 1 times 8 is 8x raised to power minus 1 over 2 equals 2. So what do you notice? X raised to power minus 1, I have 4 over 8, which is half. So our answer is option B. So it's a very tricky question. Element. So the inverse element, let's the inverse element be x raised to power minus 1. So x raised to power minus 1 combines with any element to give us e. And how do you get e from the table? So we'll look out for the same row that will give us row A, B, C, D. So let's check. So this is the row. What of column that will give us A, B, C, D? Look again, you see is this one. So what's the point of intersection at B? So our identity element is what? B. So from here, the inverse must combine with another element to give us B. So which of them? Which is this? Or that's vice versa. Either x combines with inverse to give us B. So B combines with B to give us B. So our inverse element is B, which is option B. So it's a very tricky question. Thank you.